Okay, the electromagnetic fields also carry momentum. As by definition, momentum density in the field, this is the momentum density in electromagnetic field. This is equal to mu naught epsilon naught and S. S is the Poynting vector. And whenever we replace mu naught epsilon naught, we can get C square, 1 over C square, which is equal to this. And this momentum density, which is equal to 1 over c square, and putting the value of s that we have already calculated. And then this momentum density, which is equal to 1 over c, this c will cancel with this square, and we can get 1 over c epsilon naught e naught square cosine of this. And here, this term, we know this is the energy U, energy per unit volume. We have already calculated this U. Then this momentum density will be equal to this. Now, in case of light, lambda, which is equal to 5 into 10 to the power minus 7 meter, the time period of this light 10 to the power minus 15 second. Here we are not interested in fluctuation of cosine square and the energy and momentum density. Actually, we are not interested to the fluctuation of the field, sine and cosine fluctuation. We are only interested in the energy density and momentum density. So we can ignore the oscillation here. So if we ignore the oscillation, then we will take the average value of us and momentum density. Then the average of this thing, which is equal to 1 over 2. And if we put the average in u, we will get this, and s, we can get this expression. This is a very simple, not a complicated one, and the momentum density must be equal to this. Just we can replace cosine square and the integration, the average of this cosine square kz minus omega t plus delta, which is equal to 1 over 2, then we can get this, and this term. The average power per unit area transported by electromagnetic wave is called the intensity. We know about the intensity, then the average, such as the intensity must be equal to the average of the transported of the energy, which is equal to 1 over 2 c epsilon naught e square, this one. This one. This is the average Poynting vector, and we know this, the intensity. When light falls on a perfect absorber, it delivers its momentum to the surface, and delta t, the momentum transfer will be. The momentum transfer, I have written this, the momentum transfer will be equal to this. If we see that this is the area and this is the distance. If I consider this, and let's suppose this is the area of this cylinder type, and at any time delta t the wave is propagating, then we must take distance delta t into c. C is equal to, for example, velocity, which is equal to s divided by t. Then if we take the velocity is equal to c, then c, which is equal to s, the distance, s divided by delta t. Then this distance which is equal to delta tc, and this is the area. Then the volume of this cylinder must be equal to a is the area and c delta t is the distance. Then we can get the volume. And what is rho? this is the momentum density, and momentum density we know that this is the momentum per unit volume. Then momentum per unit volume, and this is volume, this volume will cancel with this volume, and we can get the momentum delta P. We will get the momentum. Now the pressure, what will be the pressure of the electromagnetic wave when a medium is perfectly absorber. Then we know about the pressure is nothing but the force per unit area. And from this equation, if we divide delta P divided by delta T, then this is equal to momentum, rate of change of momentum. And rate of change of momentum, we know this is equal to the force. So I have written this delta P divided by delta T from this equation, which is equal to rho, the density, and AC, as the area C is the speed of light. Then putting the value of delta P divided by delta T here, the force, then this is equal to area will cancel with area, and we can get 1 over 2C if we put the value of rho E, this one. If we put the value of this, then we can get this. And finally, pressure, which is equal to this. And this thing is actually the intensity that we have already derived. And this is the intensity, then 1 over C, which is equal to I. So this is the pressure.